Okay, my A-level math student, okay, so my year 12 math students, we are told or given the equation p minus 1 in brackets x squared plus 4x plus p minus 5 equals 0, where p is a constant, i.e. a number, has no real roots. Okay, very important key words there. Okay, it's going to come into play in just a second. Part A, show that p satisfies p squared minus 6p plus 1 is greater than 0. Well, if an equation has no roots yet and it's a quadratic, it means the discriminant, so the bit underneath here or inside here, the square root of my quadratic formula, which is b squared minus 4ac, is going to be strictly less than 0. Because I can't square root a negative number, so I can't square it here, minus 3. Okay, that's not possible. Okay, so like yeah, in what we call like the real world, the real plane. Now, of course, if you're going on, obviously doing your 8th level further mathematics, then you'll learn about complex numbers. But in this video, we're obviously focusing just obviously on the pure maths A level, so no need to worry about that at this stage. Okay, but yeah, okay. So a is the coefficient of x squared, so a equals p minus 1. B is the coefficient of x, so b is equal to 4. And c is a constant term or terms, okay, the coefficient of our constants. Okay, I'm going to plug all these into here. See what we get. We're going to get 4 squared minus 4 lots of p minus 1 times p minus 5 is less than 0. Okay, 4 squared will be 16 minus 4 brackets. So expand this here, we're going to have p times p is p squared. P times minus 3 is minus 3p. Then I've got a minus 1p, so that makes minus 4p or minus 4p's. Then minus 1 times, sorry, that'll make it minus 6p. Sorry, I'll come down here. Sorry, it's minus 6p there. I apologize. I read it as a 3 there, I apologize. Okay, and then that'll be plus 5. Okay, less than 0. Okay, expand that single bracket out, so we're going to have 16 minus 4p squared plus 24p minus 20 is less than 0. Okay, rearrange this to have it as a quadratic. So we're going to have minus 4p squared plus 24p. Then I've got 16 minus 20 makes minus 4 or negative 4 is less than 0. Then I'm going to multiply through by minus 1 or negative 1. But be careful to obviously flip the inequality sign. So we're going to have 4p squared minus 24p plus 4 is greater than 0 because I've multiplied through by minus 1 or negative 1 or changed the sign, okay, for all of my terms throughout the inequality. So that obviously reverses here or switches the direction of the inequality symbol, okay. Then I'm going to factor out 4, okay, I'll divide 3 by 4. You could say we have 4 brackets p squared minus 6p plus 1 is greater than 0. And if you want, final step is to divide both sides by 4, okay, if you want to do that. These 4s are going to cancel. Okay, I'm going to get p squared plus 6p plus 1 is greater than 0, okay, as requested, okay, or as shown, okay, as shown or as required, okay, or as requested. Okay, so that's part A done. Okay, so definitely quite obviously heavy algebra there, but hopefully it makes sense. Okay, so we were substituting here into this inequality here. Okay, part B, hence find the set of values of P. So we're obviously now going to solve here the inequality. Okay, notice or note here that part B does not, so even if you get part A wrong here, heaven forbid, you can still get the full marks on part B because it doesn't require you to use, okay, but obviously knowing the previous part would obviously help, okay, but if you're unsure, you can still pick up the full 4 marks or some marks on part B without necessarily getting part A right. Okay, so this is like a good thing here for exams to have, because obviously you do obviously get your like carry forward marks in the exam, but even yeah, if I made like a horrible like mistake in part A there, okay, with my algebra, okay, then I can still pick up marks here, even in part B, okay. So I am going to, yeah, so like, I'm going to first make it equal to 0 first, okay. Then I'm going to solve the quadratic equation first by completing the square. So I'm going to have p minus 3 in brackets all squared. Then I subtract this number squared, so that'll be minus 9. Okay, coming down the plus 1 is equal to 0. Okay, I'm going to rearrange this. So we're going to have, so p minus 3 all squared. Minus 9 plus 1 is minus 8. But when I add it to the other side, that becomes positive or plus 8. Then we have p minus 3 is equal to plus or minus the square root of 8. Adding 3 to both sides, we get p is equal to 3 plus or minus root 8. Okay. Notice here that you don't have to simplify the root 8 there. Okay, it doesn't actually ask for that. Okay, so don't bother here. Okay, simplify. I mean, if you want to, you can, but yes, obviously added work if you that is not always necessarily needed. Okay, so I'm now gonna obviously sketch the curve. Okay, it's gonna look like that. So your roots are gonna be 3 minus root 8 there. Okay, and 3 plus root 8 there. And we want to know, because it's an inequality, guys, where is this curve or this parabola, okay, above the x-axis? Well, it's above it in this region here, so this part here, and this region here, okay, this part here. Okay, so the answer to this inequality will be that when p is less than 3 minus root 8 and when p is greater than 3 plus root 8. Okay, because we are looking where is the graph or the curve or the parabola greater than 0, i.e. where is it above the x-axis. Okay, so you're always looking at the x-axis or x-axis, okay, when you're solving a quadratic inequality. Okay, so where is it above the x-axis or x-axis? Okay, it's above it in this region here and this region here. Okay, that's why we have two inequalities as our answer. Again, if you did obviously simplify, yeah, if you're wondering, yeah, if you simplify, yeah, the root 8, then yeah, I can write it as p is less than 3 minus 2 root 2, and then p is greater than 3 plus 2 root 2. Okay. That is our final answer. In total, 7 marks from an old spec Edexcel Core 1 8th level maths, looking at discriminants and roots of quadratics, okay, for AS pure math students. So my year 12 and my year 13 math students, okay, they'll be going back into school or sixth form or college this September.